Hello, everyone. This is assignment 21, question 8. And this one here has to do with forming a polyester from terephthalic acid. And I've drawn it out here. Here you were given the formula for it and also told it's benzene 1,4-dicarboxylic acid. Benzene and then 1,4 or para, you could have said as well, and 2 carboxylic acids, and ethylene glycol, which is a dialcohol. Written them out like this. And in this question, you want to know how much of each of these need to be reacted together to make 10 kilograms of the polyester fiber. So the first thing to do, though, is write out the equation for this and actually write out what that polyester fiber would look like. This is one of the ones you learned in class, which is what happens if you react carboxylic acid with an alcohol, and with the main goal in mind of polymerization. We talked about condensation, polymerization, and this one in particular. So when you have condensation, you are losing water, right, out of the reaction. We're going to lose minus water. And we know that these two functional groups are coming together and reacting, and you're kicking out water. Think about where that water can come from. There's an OH here and the H right there. So I'm just going to kind of circle those guys. And so those guys are coming out, and we're going to create a bond now between that carbon and that oxygen. Let's just start by writing that down here. There is the carbonyl carbon, and now I've bonded it to that oxygen over there. I've kicked out the water. Now we can write everything else on there. So we have two CH2s. I'll put OH like that. Over here you have your benzene ring. C double bond O, OH. Okay, so here I've just shown two coming together, but this is the perfect setup for showing that this is a polymerization reaction. Because to show that this keeps going and going, this is the repeat unit. We've taken the two monomers and put them together. Now you notice at either end, here's an alcohol and here's a carboxylic acid. So this can just keep reacting with itself and keeping going, right? Or this alcohol will find another carboxylic acid, this carboxylic acid finds another alcohol, and it grows. But you don't need to keep drawing that. You can stop right here after putting just those two monomers together. First things first, you're showing that functional group, which is an ester. It's an important part. Now you want to show where this repeat unit is. Remember when you built it, you kicked out water? Same thing here. We're going to break it in order to show where that water leaves. Remember, we got rid of the OH that was on the carboxylic acid. So I'm going to break it right there. And we got rid of the H that was on the alcohol. You can break it like that. And you just put your little N right there. That's the water. That's going to show up on the end of this polymer. Remember, this polymer could be millions long. Okay? It's very, very long. But everything else in between here is just going to be a repeat over and over and over again. So that's how you would show this polymerization. To finish it up and make a balanced chemical equation, you would say that you added N of those, and you ended up with, now this is the tricky part here, is how many waters, right? So yes, minus water. You lost one water in building this guy. Then think about it, another water for every time this guy kept binding. So you've actually lost 2 N's worth of water if you're drawing out this full polymerization reaction. Okay. Yeah, now you can always do this backwards too. These are good questions to practice. If you guys just go look at a list of polymers, like say polyesters, and try and break it down to find those monomers. Look for your ester, break it in half. That's a good starting point. Okay. And then you can see what pieces had to go together in order to build that. You know, if you break down an ester, you're adding water back into it to form carboxylic acid and an alcohol. Now the rest of the question wants to know how we get 10 grams or 10 kilograms of this guy here. So I've written down the molecular weights of these starting ones. You have to figure those out. Okay, so 166 and 62. If this is 10 kilograms, you need to know how many moles this is, and you're only focused on this repeat unit. So only figure out the molecular weight of this guy right here. And when you do that, you should have a molecular weight of 192.152 grams per mole. So from this and 10 kilos, you can figure out the moles of repeat unit. So you should have 52.04 moles of repeat unit, or polyester, okay? Because you know now, stoichiometrically speaking, how many monomers went into this repeat unit. So for every one repeat unit, you added 1 terephthalic acid and 1 ethylene glycol. So it's all just 1 to 1 to 1. So you can now figure out your mass of terephthalic acid and mass of ethylene glycol. So you needed to start with, here, to start with 8.64 kilograms of terephthalic acid and 3.23 kilograms of ethylene glycol.